Hello everyone, let's talk about adding and subtracting rationals now. We've done the multiplication and division, and that's mostly just can you factor. This is a little bit more going on here because when you add or subtract, you need to have a common denominator. So in the first one, you'll notice they both have x plus 1. So what I'm going to do is say, look, they have a common denominator. It is x plus 1. And in the numerator, I'm going to put what's up there, 2x minus 1 minus x. Now, the denominator is not going to change. That's x plus 1. Once you've got a common denominator, you're good. But in the numerator, you can combine like terms. 2x minus 1x is 1x, and then you got a minus 1. So that's it. That's simplified. That one had a common denominator, not a big deal. This one doesn't. It's more work. So what we're going to do is look and say like, all right, 2 and 3. 2 and 3 don't have any factors that they share. So the only thing I can do is multiply one of them by 3 and the other by 2. Multiply them by each other. That would make this denominator 6x, but this one is 6x squared. So I need another x here. So I'm going to multiply this denominator by 3x, so its denominator will be 6x squared. And then I'll multiply this guy by 2, so they're both 6x squared. What you need to remember is, if you multiply the bottom by 3x, you also need to multiply the top by 3x. Same thing with the 2. So now in the top, I have 3x times 5, which is 15x, and 2 times 2, which is 4. And since I can't factor anything, there's nothing to factor there, and now I have it all over one fraction, that is my answer. So you're going to look for what each term has that the other needs to get to a least common denominator. So when you see something like this, you might say, well, this has a plus. Now, one thing you cannot do is you cannot add 3x squared. Adding to the top in the adding something to the top and the bottom of a fraction does not create a true statement. Let me try and convince you. 1/2, and if you add 2 to both sides, add 2 to both sides of the fraction, you're like, that's 3/4. That's not the same as 1/2. It doesn't work. You can only multiply, and the reason that you're allowed to do that is because multiplying something divided by itself is the same as multiplying by 1. So keep that in mind. Now, what I'm going to do is factor this denominator. I can't really factor 3x. That's fine. But I can factor the second denominator, and I'm going to find their GCF, which is 3x. And I would be left with x plus 1. The reason that we're doing that is it helps us figure out what one denominator has that the other needs. They both have a 3x, but this one has an x plus 1. So 7 over 3x, what I'm going to do is give this first term an x plus 1 in the top and the bottom. So that my new common denominator is 3x times x plus 1. Now the name of the game is simplify the top. 7x plus 7, and then I have plus x, which will simplify to 8x plus 7 over, the denominator doesn't change, 3x times x plus 1. So you have to factor the denominators to figure out what they're made up of, and that will help you decide what you need to add so that they are a common denominator. Let's do another one. So let's see, I can't really do anything with x plus 2, so I'll leave that alone. But in the denominator here, I'll factor out a 2. I'm going to leave myself some space because I have a feeling I'm going to need to multiply by something. I don't really care what's going on with the numerator. I'm not really even looking at it. I'm focused on getting a common denominator. Okay, so in the denominator here, you have to find numbers that multiply to 3 and add to -4. That would be -3 and -1. So what do they have in common? They have an x minus 1 in common. What don't they have in common? Well, this guy's got a 2, so this one needs a 2 in the top and the bottom. And now we got 2, x minus 1, x minus 3 here. And if you do it in the bottom, you have to do it in the top. So my common denominator will be 2 times x minus 1 times x minus 3. See that those are the same now. Now I have to simplify the top, and in this problem, you're going to have to FOIL. So you have to multiply x times x is x squared, and then you got minus 3x plus 2x minus 6. And then I'm also going to have to distribute this 2. So plus 4x plus 2. So now I will combine like terms, whatever I have in the top. And keep in mind, I'm not changing this. This stays the same. I'm only looking at the top now. X squared, let's see. Negative 3 plus 2 is negative 1. Negative 1 plus 4 is 3x. And let's see, negative 6 and 2 make negative 4. So now we've got the numerator simplified, but sometimes you can keep going. So now we need to look and say, is that factorable? Does anything multiply to negative 4 and add to positive 3? And the answer is yes. X plus 4, x minus 1. Now watch what happens. Sometimes these problems just keep going, and this is one of those. See how x minus 1 can now cancel out? So you have x plus 4 over 2 times x minus 3. There you go. So in this problem, you get a common denominator, and then after you combine like terms, you get something that is factorable, and you can keep going. And in this problem, something actually did cancel out. Let's do a couple more. Let's see, I'm going to factor the denominators, and then I'll figure out what each one needs that the other has. This is x minus 1, this is x. So what multiplies to 3 and adds to 4? 3 and 1. This is dots. X plus 3, x minus 3. And there's a plus sign here in the middle. Let's put a plus right there. I probably should write it like that. All right, so x plus 3, x plus 1, x plus 3, well, this needs an x minus 3. And if you do it in the bottom, you have to do it in the top. X plus 3, x minus 3, this needs an x plus 1. And if you do it in the bottom, you have to do it in the top. So my denominator will be x plus 3, x minus 3, and then x plus 1. Now that they have that denominator, I'm just looking at the top. So I will FOIL x squared. I'm going to do this in my head. Minus 3 minus 1 makes negative 4x. Negative 1 times negative 3 is positive 3. And then plus x squared plus x. So my denominator won't change. I'm just going to copy that. But now in the numerator, I have x squared plus x squared, 2x squared. Negative 4 and 1 make negative 3x, and then plus 3. Does anything multiply to 6 and add to negative 3? I don't think so. So I won't be able to keep going on this one. This is my answer. That's all I can do. Okay. Messy, but it's okay. Let's try one where the factoring is a little more difficult. So I have 3, and then I have this guy. So sometimes just because it becomes a bit overwhelming with too much information, it helps to factor this like off to the side. So the numbers that multiply to 12, 3 times 4 is 12, multiply to 12 and add to 7 are 3 and 4. Notice, if it's not a 1x squared, you have to split the middle. So plus 3x plus 4x plus 4. X plus 4 x plus 1. All right, so that is my denominator after I factor it. I'm just going to take this and say, hey, that's the denominator. Okay, that's all the work for the factoring. That's the split the middle stuff, but I don't need that once I have the answer. Plus, I have x plus 5, and then my denominator is x plus 1. I can't factor that. But I do see now that they share an x plus 1, and this one will need a 3x plus 4, which I'll have to FOIL. 3x plus 4. And now that I have my common denominator, I'll just write this over that denominator. 3x plus 4 times x plus 1. So in the top, I got a 3. Now I have to distribute 3x squared plus outside and inside. Plus 4 plus 15 is plus 19x. And then 5 times 4 is 20. So when you combine like terms, 3x squared plus 19x plus 3 plus 20 is 23. And the denominator doesn't change. So x plus 1, 3x plus 4. All right. Does anything multiply to 3 times 23? So 3 times 23. Why isn't this working? Oh, duh. 3 times 23. 69. Does anything multiply to 69 and add to 19? Let's go. Let's look at all the factors. I'm going to do 69 divided by x, and do any of them add to 19? 1 and 69, 3 and 23. That makes 26. I don't think so. So I'm done. I can't keep going, but you got to check. Sometimes these are factorable. This one, though, nope. We're done. The other thing you can do if you're not sure if something is factorable is you can do the discriminant, b squared minus 4ac. And if that's not a perfect square, and 85 is not a perfect square, 81 is, then you know it's not factorable. So I don't even need to look for the numbers. But it's a good trick to have. All right, so I'm going to do these practice problems pretty quick. The first one, it already has a common denominator, so all I can do is say, look, it's 3x plus 1, and in the top, I'll write it as x plus 2. That's all you can do. 3x over x minus 5 minus, this is dots, x plus 5, x minus 5. So I'll give this one an x plus 5. So my denominator will be x plus 5, x minus 5. And now when I distribute, 3x squared plus 15x and then minus 2. Just because I just showed you, let's do the discriminant. B squared minus 4ac. Is that a perfect square? No. Oh, actually, yeah, it is. That's, no, it's not. You're good. If it's not a perfect square, you don't need to keep going. Okay. Now, this one has 3 terms. We haven't done one that has 3 terms, but it's the same game. So I'm going to show you this is 3 over x, this is 2 over x minus 2, and this is negative 2 over x squared. So let's see. This one definitely needs an x, and this one needs an x squared. So this has x squared, it needs an x minus 2. So x times x minus 2. This one just needs an x squared, and this one needs an x minus 2. So the common denominator has to be between all of the terms. So it's x squared times x minus 2. What's in the top? 3x squared minus 6x plus 2x squared, that's just 2x squared, and then minus 2x plus 4, because you got to distribute. Combine like terms, 3 plus 2 makes 5x squared, negative 6 and negative 2 make negative 8, and then you got a plus 4. 5, or no, this is just x squared, x minus. I think that's it. Does anything multiply to 20 and add to negative 8? I don't think so, but again, to make sure something is prime, 4ac, negative 16, yeah. So that's definitely not something I can factor if it's if the discriminant's negative. I'm finished then. One more. This term needs an x, and this term needs a 7. So my denominator is 7x, and in the top you have 3x squared minus 5x. But you can keep going, factor out an x, and you can cancel that one out. So 3x minus 5 over 7. Remember, GCF is still fair game too. Okay, if there is a GCF, factor that out. All right, last 2 are just more trinomial problems, so let's see if we can factor them. What multiplies to 3 and adds to negative 4? X minus 3, x minus 1. So this one needs an x minus 1 in the top and the bottom. Okay, this had an x minus 3 and an x minus 1. This one needs an x minus 1 in the top and the bottom. So in the top now I got x plus 5x minus 5, which will be 6x minus 5. And the denominator still is not going to change. Okay, just leave it factored and you're done. There's no GCF, so I know I'm finished. All right, this one might be messy. I got 3 fractions. I'm going to give myself some space. X over x plus 3 minus 3 over x plus 2, and then what multiplies, minus as well. What multiplies to 6 and adds to 5 would be 3 and 2. Okay, so you hopefully see this one needs an x plus 2 in the top and the bottom. This one needs an x plus 3, so I don't know if I can fit that. X plus, I didn't give myself enough room. X plus 3, and this one's fine. So once your denominator is set, x plus 3, x plus 2, I got to distribute. X squared plus 2x. This is negative. Minus 3x minus 9, and that's also negative. Minus 1. Does anything multiply to negative 10 and add to negative 1? I don't think so, but just because I've been doing it, let's show you the discriminant again. B squared minus 4AC. 41 is not a perfect square. This is not factorable. I'm finished. Okay, two more. 2x over, let's see, what multiplies to 4 and adds to 4? X plus 2x plus 2. Plus x minus 1 over x times x plus 2. So, let's see, this guy needs an x, and this one needs another x plus 2. So my denominator will be x times, I'm going to write it fancy, x plus 2 is x plus 2 squared. In the top, you have 2x squared, and then you need a FOIL, x squared, plus 2 minus 1 will give you plus 1, and negative 1 times 2 is negative 2. This might be factorable. What multiplies to negative 6 and adds to 3? Plus 3x minus 2x. So look at this one. If I factor the top, I'll get this. And notice nothing's going to cancel. So it really doesn't even matter if I do. Okay, I tried it, but it didn't matter. Okay, the numbers that multiply to negative 6 and add to positive 1 are 3 and negative 2. I tried to factor, but if you put that there, nothing cancels. So it doesn't really matter. Okay, you just want to check to see if it can cancel. Last one. Now, this is kind of tricky when it's a 1. It just bothers people. You can't do anything with this denominator, but that means this one needs x squared minus 2 in the top and the bottom. Okay, because right now its denominator is 1. So x squared minus 2 will be in the bottom. Now when I distribute, 2x squared minus 4 plus x, which I'll write like this. And then I have x squared minus 2 in the bottom. Does anything multiply to negative 8 and add to 1? No, I think I'm good. All right. Oop, I can't see that though. There we go. All right, so this is something that's going to take a little practice. You're going to need to be real strong at factoring to have a lot of success here. But if you are strong at factoring, you'll be able to get there pretty quick. So make sure you hit that like and subscribe, and have a good day.